Welcome back everyone. It's been a while since I posted any major videos onto my channel, and it's about time that I start cleaning up some of my procrastination projects. And today's procrastination project is my T1 Reading locomotive, which has been in hiatus for the last 3 years. And why did this happen? Well, I will explain that towards the end of the video. But right now, this was my first T1 484 locomotive that was put on my layout about 3 years ago. I did a quick lubrication on it and it ran very well until it started to slow down. And I thought, hey, that would be a great time to do a teardown and rebuild video with improvements and post it online. But little did I realize that I have taken on a basket case of a locomotive, which again, I will explain at the end of the video. So right now, let's take apart the locomotive, clean it up, and give it some upgrades. So let's get started. When you are taking apart your T1, be sure to keep all of your parts in a line diagram because it'll make it much easier to put the locomotive back together. The bushings for the wheels feel nice and smooth, and as you can see as I spin them, that there is no wobbling or any kind of vibration that would slow them down. However, looking into the gear housing, it looks like that this locomotive has been serviced before because this grease looks like something that Lionel would not use. While taking apart the smoke unit, the paper-thin gasket broke onto me into 2 pieces, and then when it dried out, it broke on me into 4 pieces. So I had to tape it back together, and we are going to make a new gasket out of new gasket material. When I took the cover off the gear housing, the gasket on there started to tear on me, so I'm going to make a new gasket for that as well. We're going to upgrade the smoke unit resistor from a 27 ohm resistor to an 18 ohm ceramic resistor, and we're going to put a new LED light in place of the incandescent light with a custom DC power supply for the locomotive headlamp operation. With all these intentions I have for the project, let's go ahead and start cleaning up the main gear in the locomotive frame. So to get all the grease out on the inside, I'm using this toothpick and I'm just going to kind of scoop inside and just kind of pick it out like so. This looks like automotive grease to me. I got this makeup tool Acne needle kit at a dollar store, and I'm going to use this angled pick to clean out the gear inside of the frame. So I'm just using this as kind of like a scoop where I'm going to go into the gear and just start to scoop towards myself, so I'm picking up any debris if there's anything in there along with the grease, just so that we have a nice clean gear when I apply new grease. We're going to take Blaster heavy duty engine degreaser and we're going to spray it on the inside of the gear housing here. This will take care of any of the hard grease or stuck grease that will help break it up and loosen it up. Kind of mix it around a bit just to kind of help break up anything in there, loosen it up. Again with another toothpick just to kind of help things out. So I take the frame and I put it under a tray with a paper towel, and I can just kind of dump out all that stuff. And you can see all the grease that's coming out. Under the frame we have this screw, and let's get that removed. Just clean out any grease in here with a toothpick just so that it will not be clogged. A little more engine degreaser. Come on, there we go. Kind of spin this around, mix it up. And then we should see it come out of the bottom. I'm going to use some WD-40 as a final clean out. I decided to let the frame sit for about a day and then come back and spray it again with WD-40 with the frame upside down, and more grease was coming out and more chunks too. And the paper towels are more yellow-green than what you see here on camera, so a lot of it has turned to liquid within the last 24 hours. Final cleanout was achieved using an air compressor. Be careful when doing this because you will get loose grease and WD-40 splattered all over you. I will clean all mechanical surfaces with WD-40. Anything that has an electrical contact surface, like the pickup rollers and the front and rear chuck axles, I will clean with Inox MX3. It only seems the one end here wants to come apart, and that's it. It's just two thrust washers and this bearing, but this side here will not come off. So this is going to make it a little more tougher to clean with the toothbrush and the acne needle tool. This is what happens with a lack of lubrication in your drive system. The bearings were digging into the thrust washers, so I ordered a new set shown above. Okay, so just before I assembled the locomotive here, I realized I'm going to have to start from the bottom up with this, because if I just start putting everything on top, I'm going to have no way of installing this pickup wire onto the chassis for the locomotive. So having the worm drive universal shafts sticking out here, I'm going to have no access to the screw once it's installed to tighten down this lug. So we're going to have to install the rollers, get them in place, which these will be cleaned with Inox. And you'll notice here I have a second wire next to this pickup wire, and that's because I made this wire longer. Lionel somehow, when they made these wires, they made them to a perfect length to where they're going to be tight across metal surfaces, especially across the cover here for the worm housing. So I'm using 18 gauge wire and the V31 terminals, so I can have a little more relaxed wire installed on this, and it'll be a little bit more comfortable to work with, plus it'll handle the higher current of the 18 ohm ceramic resistor that I will install. Here's the gasket I made. It was a little wider, so I just trimmed the edges, but yet fits okay on there. To assemble our E-unit housing onto the steam chest, there's these two fingers here on the pushrod assembly slides, and these two fingers, they'll go into the two square holes here right above the pistons. So this we can assemble just like so, and again, it's going to feel pretty sturdy in place. So we're going to take our smoke diffuser, install that into place, take our piston push bar, install that, and everything goes right in my favor. Push up the bar here. I can probably tweak it a little bit. Have this set right in place. Come on, it's gotta lock in. There we go. Perfect. Even though it feels firm, it still has to get screwed in place. And we can see that the push rod lever had to get installed because this mount holds it in place. So I temporarily installed this long screw to keep in the E-unit housing, so I can flip this over with one hand and install the screws for the steam chest. So we're going to assemble the push rods onto the locomotive now. I did find that it is best if you lay the locomotive on its side to install the push rods. This way you can get all the rings and everything else, all the screws, into their mounting holes. Now I did find when I installed this push rod on this side that working on this side here, these the rods are separated by 90 degrees, so you see that they're on top of here, and over here it's 90 degrees to the right. And this is how I installed them, because this push rod here, it does have a set of teeth in it that when you push it into its housing on this wheel, it's supposed to stay in place. There we go. So you see that it does not move, and setting it up like this will not bind it in any way. Now I did find that you may want to work on the gearbox last, so that you can freely spin these wheels around when you do install the push rods. So yeah, it's a lesson learned for this one here. I'm going to remove the incandescent fixture by cutting the wire close to the E-unit, and then I'm going to cut the resistor leg close to the smoke housing. I have to save the fiberglass tubing because I need to install that onto my new 18 gauge wire that I soldered onto the V31 terminal. I'm going to start removing the old smoke resistor by cutting that wire close to the smoke housing, and with a little force it pops right out. With the new 18 ohm ceramic smoke resistor in place, we can see how it sits, and we're going to solder on the new wire onto the resistor leg and slide the fiberglass tubing over it. Alright, so I tried to make this gasket as close as I can to the existing gasket, and just cut it with the outside with scissors and the inside with a razor blade. But when you try and make something as close as to the original as you can, well, I kind of tore the corner on this and it may not act as good. So just to give you an idea that it does sit really well on top of the smoke unit here. But again, the end is torn and I don't want anything coming out the sides. So I went ahead, I made another one, but this time it's a little more thicker around the walls, and I placed that on here, and it sits very nicely onto the smoke unit here. However, you see I do have a little notch right here in this corner, and that's because on the bottom of the smoke unit there's this groove right here that sits right inside of this channel. So in doing so, when we line this up, we're going to take this, and I pushed in the resistor wire close to the housing as I could. Oops, drop that. And I'm just going to set that right down in place. It'll give a good seal, so all we got to do is just screw it in. The LED, which I also got from Amazon, is 3-volt operational, and you can see that there is black and red identification markers, and that tells you what end is going to be positive and negative. It's just wire jacketing I put on there just to help identify the positive and negative. The main frame of the T1 has been assembled, and a test run has shown that the locomotive is still running slow. Now, whenever I take apart these Lionel locomotives, I always perform a Megger test on these pull-more motors just to ensure that there is no voltage leaks or anything coming from the motor, which can affect the performance of the locomotive. So to take out this armature, the first thing that we always do is we always take off the brush plate. But instantly from here, I can tell that the bushing is bad inside the motor housing because the armature is very wobbly. So I'm going to have to get that fixed. Attached to the armature, we have to remove the universal joint off the aft end of it. So we're just going to tap that off. And there's also a C-clip at the bottom of the motor housing, which we have to take off. And once we got that off, the armature comes right out. So from here, I take my Megger, I take one of the clips, I put it on the commutator plate, and the other clip I just put onto the armature shaft. And when I push that test button, it shows right to bad. So a further investigation did show that one of the magnetic wires has been overwound on the segment, which is creating this short, and I will have to get that motor rewound. Now, once I get the motor rewound and I put a new bushing inside of the motor housing, I want to put everything back together. And to a surprise, everything was not going as smoothly as it was. Because when I went to put the brush plate back on, it was very hard to get back on, and I was not applying a lot of pressure. So I'm looking if there's anything obstructing it, any debris or anything that could be stopping it from going on. And there was nothing wrong with it. Until I made a discovery that there was either a machining defect in the motor housing or the brush plate, but either one of them showed that the armature was not sitting properly inside of the motor housing. And here's what I found. I'm going to use this old motor housing and armature for this demonstration. After I replaced this with a new bushing and I went to put the new armature back in my rewound armature back in the motor housing, everything was fitting fine, but the brush plate was not lining up and was very hard to put on. So I just made sure, again, no obstructions, nothing going on. And what I found out was that the bushing was actually worn at an angle inside of the motor housing. So which means that this armature was sitting not perpendicular as I show it here, but at an angle like this. Now, of course, that this is exaggerated, but if you looked closely at the motor when it was sitting into the housing, you could tell that there was a slight pitch to it inside of this. And this, I believed, was a cause for the power loss that I had on this locomotive. So I placed a new order in for another motor unit, just the motor housing and a new brush plate. And when I got those parts in and I put everything together, the locomotive was still running slow. It still had this performance issue. So, okay, so now I'm going through the troubleshooting and everything, and all of a sudden the locomotive just conks right out on me. It just stops. So the E unit was not cycling, and then I looked at the drum. It broke inside of the E unit. So I'm like, all right. So now I went over to my Lionel modern day era Greenberg's manual, and I ordered a new drum from here from what they recommended. I had it installed, and again, I still had the same performance issue, and I continued my troubleshooting procedure from there. So now I'm looking at any of the existing wires that are on the locomotive, and I'm looking at the E unit fingers coming from the E unit over to the motor. And I noticed that on the blue wire that it has been overstripped, because we can see that there has been some of the copper conductors that have been peeled back, or that you could actually see that they're broken. And this is a point of failure, because now you are reducing the current going to your motor, and this could be a potential heat point, which is now changing the chemical compound of the copper, creating resistance, and this could give you a slower motor, or again, more performance issues. I mean, it could be anything. So, you know what? I went up on eBay, picked up a new set of fingers for my E-unit. I had those installed. Nothing. No change in performance. It was still going slow. I mean, at this point, it's a brand new locomotive. It's on the track, brand new wiring, practically brand new everything. I mean, why is this going slow? I'm not accepting that this is how this locomotive is supposed to run. So at the one point of testing, it just stopped completely. I'm just about had it at this point. And now I'm looking up online the drums, because maybe this is probably the drum that I was just given off of like eBay or something. So I did order another set of drums, and I got a 5-pack of it. And when I got the drums in, put it in place of the one that was giving me a problem, and then I had success. The locomotive was running fast, it was going around the table, and I had no problem with it. It was running smooth. So to finish up the project with the LED headlamp, I just took some heat shrink tube, put it over the red and black wires. I soldered the LED onto those wires and took those heat shrink tubes, put it over the solder joints up the legs of the LED. And then I just cut a piece of 3/8 wooden dowel about 1/2 inch long. Maybe I could have gone a little shorter than that. And then just suck the LED on there to the wooden dowel with a bigger piece of heat shrink tube, assemble that into the lamp assembly clip, angle the LED, and put it all together. At this point, I'm very happy. I'm satisfied that the locomotive was finished. I put it on the tracks, ran it around there, and it was running the way that I believe it was supposed to run. And then all of a sudden, something started to happen. It started to run slower. It started to slow down in speed again. I'm like, this is not happening. It's not. When it passed me and it started going to the back of the table, it greatly reduced speed. And I'm hoping that when it got around to the front of the table, I could get it. But as I round that corner, poof. A puff of smoke came out of the boiler. The locomotive stopped dead on the tracks. There was no short indicated on my ZW, but the locomotive light was still on. I mean, what can this be at this point? I mean, anything. So I took the locomotive off the track and I brought it to my work table, and I'm looking at all my wiring, making sure that there's no pinched wires, nothing. And then I look over at the E unit and I started to see some melted plastic on the inside of the E unit. And I took it apart, and here we could see the damaged drum that I just installed, and we could see that one of the fingers was vaporized on the E unit. This was completely new to me, and I've never ever seen anything like this before. So, all right, I gotta find something what's going on with this and why is this happening. So I put the E unit back together again with another finger and another drum, and now I started to do testing. I only wanted to test the current coming from the motor at full speed, so I disengaged my headlight circuit, I disengaged the E unit coil, and I also disengaged the smoke unit. So I let the locomotive run around the track at full speed, and I was getting 1.4 amps of current going through the locomotive. So I'm like, okay, that's pretty nominal for that to run. Maybe the problem's in the tender. So then I connected the tender to the locomotive. Maybe I got a short in there somewhere. And at full speed, I'm getting 1.75 amps of current. All right, so obviously there's nothing wrong with the motor or the tender. But then I went to look at the E unit again and see what the problem was. And here's what I found, and I'll show it to you on this poster paper. This is the drum that I have purchased for my T1 and gave it its very short successful run before catastrophic failure. And in the drawing that I have over here, I'm going to be showing this area of the contact on this drum and why I had a failure. So here we have the drawing of the drum looking down it, and here we have our prawl, the green drum along with the copper contact on top and the copper contact on the bottom, and here is my finger going out to the motors. Now, in my observation is I took the prawl and I raised it all the way up into the coil manually, and I made sure that there was no binding or anything or obstructions in the prawl that allowed allowed this thing not to spin properly. So once I ruled that out, I then looked at the drum here on what happened. So with this prowl all the way up, this finger right here, the curved section of this finger, was just barely on the edge of this copper contact on the drum, which yielded a poor connection, the reason why it heated up and the reason why that the finger vaporized. Now I know that there was proper tension on this finger because when this finger vaporized, you could see here along this side that the indent of the square of the finger showed where it vaporized and stopped on this copper contact on the drum. So I know when I assembled it, there was proper tension on it and I had no problems whatsoever. I did try different drums on this E unit to see if maybe there could be a spacing issue on this. I'm not really sure. But every result, I got the same thing over and over and over again. No matter what drum I put here, this finger always wound up on the edge, if not almost into the green area here of the drum. I rotated the drum so the fingers in the E unit can fully seat on the copper contacts. I put the locomotive back on the track and disengaged the E unit coil. I let the locomotive run around the track a good number of laps and there was no performance issues or slowing down, telling me that the mechanical flaw in the E unit caused the electrical failure. So I need another E unit for this T1 and I wanted to control this locomotive with more modern technology. I went to Labelle Electronics and I picked up their 4 amp electronic reversing unit along with purchasing their 90-degree ribbon connector because I knew I had physical restraints inside of the boiler housing. And I also picked up their toggle switch to control the locomotive with forward neutral, reverse neutral forward operation. And right from the get-go, I knew that this was going to be a custom project because this new E unit had to go in place of the old E unit. I went to Amazon and I picked up their 1" by 1" angled aluminum stock, and I had to make a custom bracket that would fit in place of the old E unit so the new E unit can sit there. But my problem was a lot of clearances inside the boiler casing, and I had to make sure that I had to trim the bracket enough to where I could have the new E unit sit there without interfering or touching the boiler casing, creating electrical issues. And once I made sure all of my clearances and everything was good, I had to make sure that there was no other wiring that may interfere with my new aluminum bracket. And the only wire that I found out is my smoke unit wire. So I had to trim out a small gully on the side of it so that the wire can rest comfortably while operating the smoke unit without creating any electrical issues. Now, once I was happy and satisfied with all this, I took the boiler casing, I went to put it over the new E unit, and found out that the new E unit is wider than the opening of the boiler housing. So to take care of that, if we look here at this picture, we can see that A is pointing to what the underside of the boiler casing looks like, and while B, I had to trim it away to this shape to make it fit over the electronic reversing unit. Now, even though there is some metal taken out from this, you can not really see it much at the bottom of the locomotive, so you're not really going to see much of this metal taken away. I mean, if you do look at it, you could probably see the aluminum bracket that I made for the E unit, but that could just be easily covered up by using paint or a black magic marker, and you'll never see it again. So again, it's very minimal metal that I took off of the boiler casing. Now, once I was finished with that, I had to install my toggle switch into the cab. And I took my drill with an angled connector and a drill bit, and I drilled from the inside of the boiler casing into the cab. I had to use my Dremel tool with a grinding stone and grind off a valve, and then I installed my toggle switch. I had to extend some of the wires to make everything to work, and once I was happy with everything, I took a spiral wire organizer, I wrapped around all my wires, and made sure that all the wiring was kept neat inside, that I wasn't going to have any pinch points. The one thing that I did look at was looked at the brush plate, because there was some metal protrusions facing upward towards the top of the casing, and I had to cut those out so that the switch wires would not be affected by any of those and creating electrical issues affecting the operation of the locomotive. So once I took care of all those issues, I put the casing onto the locomotive frame, assembled everything, and the locomotive ran perfectly around the layout without any issues whatsoever. It ran fast, it ran strong. I put a bunch of heavy loads behind it, and the locomotive It didn't bog down, nothing. I let it run for a good long time. No issues whatsoever, and I'm very happy with this new E-unit that I have placed inside of this T1. So why did this project take as long as it did? Well, I am a husband and father, so I'm spending a lot of time with the family. Also, my job is I am an electrician, so I have a lot of projects placed on my lap, from new construction to troubleshooting. And within these last 2 years, I had a lot of troubleshooting projects I had to look at and get those repaired. And coming home and wanting to work on a T1, it wasn't going to happen, so I had to put that off to the side. Also, working in those polar vortexes and heat waves, just kind of wipes me out, so just didn't even want to work on it then either. I've also done some updating in the house with some new paint and everything else, so that's why we see that the basement walls here are a nice blue color. And updating the train table with a nice green coated paint, a new track plan, doing YouTube shorts, and some small train projects here in the basement with my son. So hopefully that this will be the end of my procrastination projects, so I want to get those out and placed online as soon as I can. And I hope you all have enjoyed this production. Like, comment, share, subscribe, and I'll see you all next time.